Hi everyone, a few days ago on Twitter I put up a question. Which planet, on average, is the closest to every other planet in the solar system? Now, a lot of people actually got this question right, which I was very proud to see. But some people were like, well, why is this so? And I know other people have done a video on this, but I thought I'd make a little demonstration for you all so that you can know why it is the case that Mercury is the planet in the solar system that is closest to all the other planets on average. Now, to understand this problem, we're going to need three things: some paper, a pencil, and a compass. Now, the problem most people have when looking at this problem is they're thinking of the solar system as in the one pictured in many of the textbooks you get at school, where you have the sun and you have Mercury, Venus, Earth, Mars, the asteroid belt, Jupiter, Saturn, Uranus, and Neptune. When you look at this solar system and somebody asks you which planet on average is the closest to all the other planets, you're liable to go somewhere in the middle. Maybe Mars, maybe Earth, maybe Jupiter, without thinking of the actual relative distances between these planets and the fact that the planets don't stay in a straight line. The planets move in orbits. Now, orbits are a fascinating thing. They're circular. So if you take a spot in the middle that would represent, in our case, the sun, because it's the center of our solar system, and you pick a distance of orbit, and then you trace an orbit around that central point, then what you're going to find is that the closest point to every other point on this circle is the center, the radius. That distance is the average point to the distance to all the outer points on the circle. Now, I realize that orbits within our solar system are not circular, they're elliptical. But the variation from the elliptical for most of the planets is minimal in the terms of the solar system. If you shrank the solar system down so that you could draw it on a piece of paper, well, not only would everything on it be immensely tiny, but all those orbits to our eyes would appear circular. So in this case, you can see that the closest point to every point on that circle is going to be smack bang in the middle. But another interesting thing happens. If you take another orbit around the same object, let's make another orbit. So if you take two planets in orbit around this sun, say here and here, on these two orbital paths, sure, when they're on the same side, for want of a better word, of the star or the sun, they will be closer together, this distance, than this planet is to the sun. But what happens when this planet is on the opposite side of the sun? Now, the distance here is going to be 2 radii plus the difference in the orbital distance. Now, that is an awful lot further distance than this. And if you look at the actual orbital paths of these planets, you will find that it's only in a very small arc within their orbits, when they're on the same side of the Sun, that this distance is going to be less than the radii from the inner planet to the Sun. But what has this got to do with Mercury being the planet that is closest on average to all the other planets in the solar system? Well, Mercury orbits incredibly close to the Sun. Its orbital period is only 88 days, and it orbits very, very close. Which means that at any one time, barring a very, very small, a lot less than 1 AU, because 1 AU is the distance, say, from the Earth to the Sun, radius, Mercury may as well just be the Sun. It is pretty much smack bang in the center of our solar system, like the Sun is. There's only a small minor difference. So at any one time, Mercury, like the Sun, is on average closer to every single planet in our solar system than any other planet is. I know it seems counterintuitive, but the fact of the matter is, when you've only got a small area of the orbit where 2 planets that are on nearby orbital paths are closer to each other than the closer one is to the center of the solar system, then these extra distances around here, on average, when you add them up, come out well ahead of these distances which are closer. Which means the total average of distance between these two is going to be a lot further than it is between this planet and the star, or the really close planet in the middle. Now, it doesn't necessarily have to be the really close planet in the middle. If you moved out to, say, Venus, Venus is our next planet out. If we drew Venus in here, we have the same problems here with these orbital distances. A lot narrower arc, the arcs get wider as you get further out, but they never get past this halfway point. So, but even Venus to Earth, you've still got only this small arc of the entire orbit where Earth will be closer to Venus than it's going to be to the Sun. So on average, when you add it up, Earth is closer to the Sun than it is to Venus. But also, Venus, if you weren't counting Mercury, and you're not counting the Sun, would have the same properties for Earth and, say, Mars. You're still going to have the case that these paths, and because of how close Venus is to the Sun compared to the next planet out, it too would be closer on average to the other planets than a planet that is further away from the Sun. And this carries on throughout the entire solar system. And it's all because of circular or elliptical orbits, and the fact that when you're on the opposite side of the star to when you're on the same side, the distances between you and that planet grow massively. And you only have this small arc for each one where it's closer than something where it's closer to that planet that's further out than it is to one, or the star that is closer, that is more near the center. So I hope you've enjoyed this and maybe learnt a little bit about why Mercury, on average, is the closest planet to all the other planets in the solar system. Now, if you like this video, please give it a thumbs up, and don't forget to subscribe and ding 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 that little bell, just so you know when I've got new videos coming out. And please try not to choke on the selfie stick.